Yes, so I'm only making you do the first one, only doing this for f of x. You have to find the derivative of x, where the derivative is equal to 0, graph your function, that's the original function, f of x, and find your relative maxes and mins, and then what do you see? Do you see any connection between anything? So this is sort of your exploration into what the first derivative can tell you. F prime of x, so you can find like the second derivative. The derivative of the derivative, yes. We'll do that later. So guys, I'll give you some time here, jot it down, go through that, talk to each other as you're doing it if you need to. And so again, this is there you go. I tell you to grab that's why thank you.
Oh, my brother didn't do that.
Staying math works throughout their a lot of the story.
Wait, is this for
They teach all the but some of them All I did was change it. Yeah. Yours was huge, and so it was so big because it was just too. It's so small. Yeah. Zoom standards are there. I hate Zoom content. Because it doesn't fit the right thing.
So that's it.
Give you another minute here to talk to each other. You guys remember how to calculate your min and max, right? To actually calculate it, not just trace and guess? Yes? Okay. Good. Second trace, which is calculate minimum. Yes. I mean, literally, some people will just hit trace and like arrow over and be like, well, that looks pretty close. And like, oh, no. Mm-mm. Well, that's what we're going to figure out with derivatives. So yes. You're like, oh.
No, like I spoiled it for myself.
You did. It's okay. You're just ahead. Are you guys ready to talk about this one? Yes? Okay. So let's find f prime of x. I'm assuming you guys all use shortcuts. And you got 3x squared minus 12x? Yes? Okay. Then find where f prime of x equals 0. So that means I'm going to factor. And did you get at 0 and 4? Okay. Then we went back to the original function and you graphed it on your calculator. So for this, check, we graphed it. For your maxes and mins, did you get 15 at x equals 0 for your max? And negative 17 at x equals 4 for your min? Yes? Okay. Do you notice anything?
Yeah.
What do you see here?
The zeros of the function or the x values of the function relative.
Yes, that's absolutely what you should be noticing. So the zeros of the derivative are where your original function is going to have a max or a min. Okay, that's what's called the first derivative test. So, yes, you can find where those maxes and mins are algebraically now because you know it's connected to the first derivative. Okay? So, the zeros, or let's see, we'll write it just this way. Where f prime of x equals 0 is the same as the x values of the max or of f of x. So those are called critical values. Or critical numbers. Does that make sense, guys? And so if we've been doing this all algebraically and you got this 0 and the 4, how would you find this 15 and negative 17? In the original. Good. Okay. All right. So let's first just define critical numbers. Do you ever have those days when you write a word and you swear that you have no idea how to spell it all of a sudden? Does that happen to you, or is that just me today? Critical does not look right to me. Maybe. No. All right, so this happens when the derivative is equal to 0. Or there's one other time when we get a critical number. Anybody have an idea of what it might be? What else is weird with a graph? Like, what other thing could happen? What have we talked about a lot with graphs? Okay, good, but no, that doesn't help us. Asymptotes? How does an asymptote happen? When it's what? What's that word called? So discontinuity, or we could say when it's undefined. Okay, we got there. So those are the only two things that can give us a critical number. So you set your first derivative equal to 0, and then if there's any other place where it would be undefined, those are the places where your original graph is going to have a max or a minimum. Okay? Yeah. So like say your derivative ended up being a fraction, like something over x minus 4. Well, it's not going to equal 0 at 4, it's going to be undefined at 4. But that's still going to tell you a max or a min from your original one. Okay. All right, you ready to try a couple? I don't know why there's so much space there. There it is. So you're going to find the critical numbers, and then without your calculator, we're going to find the max and the min and decide where it's increasing and decreasing. So I'll let you jot down the instructions, and then I'll scroll down. Again, I don't know. Why is there so much space? Ooh, I can move it. It's a good day, guys. We're going to do 2 of these, and then that's the end of your notes for today. So it's a very short day. How you doing on finding the maximum in? Okay. Or at least those critical numbers. You want help finding the increasing, decreasing? Okay, let's get through that part together. So, did we start by finding g prime of x? Okay, 3x squared minus 12, right? Okay, then we are setting that derivative equal to 0. And I'm going to go ahead and factor out my 3. So I have x plus 2, x minus 2, right? Still with me there? Okay. So what are your two critical values where something's going to happen? 2 and negative 2. Okay, we're going to set up a number line. We know at these 2 points the value is 0 of our derivative, okay? We need to figure out if it's positive or negative in between, because that positive and negative, that's telling us if the original graph is increasing or if it's decreasing, okay? What value do you want to test? 0, yeah. So if I plug a 0 in, that's in between the two, that would give me a positive times a negative. That's overall a negative, right? Yes? Hannah? No? Sarah? What? Oh, the derivative, like the factor, just thinking about this. Okay, so if I plug 0 in, that's really positive 2 times negative 2, which overall is going to give me a negative number, right? Okay. Is this going to alternate nicely? Do you remember how or why? Or yeah, there's no multiplicity, so it's going to alternate. Okay, so that makes this positive and this positive. Change colors here so you can't see what we're doing. Okay, so we know at negative 2 and at 2 it's going to change direction. Something's going to happen. So we need to think about if it's positive, that means the original graph is increasing until we get to negative 2. Then between negative 2 and 2, your graph is going to be decreasing. And then at 2, it's going to start increasing again. So what does that make negative 2? A max or a min? Okay, so you have a relative max of, we'll figure it out, at x equals negative 2. And then do you guys see how 2 is going to be your relative, that's incremental, relative min? I cannot write today. Something at x equals 2. Let's figure out what those values actually are. So again, where do we plug in that negative 2 and 2? The original. So if I am finding g of negative 2, it's negative 2 cubed minus 12 times negative 2. So negative 8 plus 24, what do I get? 16. So we've got a relative max of 16 at x equals negative 2. And then I've got to find my minimum. So plug the 2 in. So I get 8 minus 24. What do I get this time? Negative 16. Okay. And so what would you tell me about increasing and decreasing? Where is it increasing from? Okay, and again from, okay, and then decreasing, negative 2 to 2. Questions?
So,
Yeah.
would it be wrong to like find the coordinates of the maximum and just like figure out
Well,
if we have to do
the number line is going to make it a lot easier because there's going to be some where when we get into like changes in concavity, like you're going to want to have
because like I said,
practice these with the number line. The end behavior would be a great way to check to make sure like, oh, does that make sense? Like that is a maximum and yeah. Okay. All right, guys, questions on that one? It's a lot of stuff you've seen before. Like, we've done maxes, mins, increasing, decreasing. You've just never found them with the first derivative, okay? So you now just have a way other than your calculator to find these pieces. Yes. So the derivative is the slope of the tangent line. So what that means, so this graph, if I actually graphed x cubed minus 12x at negative 2, I'm up here at 16, and at positive 2. So like your graph, that's the graph of g of x. Okay? So derivative tells me slope of the tangent line, and I'm telling you the slope of the tangent line at negative 2 and 2 is 0. So think about that. There's my tangent line. There's my tangent line. Does horizontal lines have a slope of 0? So that's why you know that's a max or a min, because the slope of the tangent line is 0. It's right at the top of the little hill. Good work on your copy. Sure, does that make sense? Okay. You sure?
I mean, I am.
So if the slope is 0, like that just means I've got, like, whatever the graph is, you know, you can have all sorts of craziness going on. What's the slope there? Right, because the derivative is not telling you anything about these points because it's not zeros of the original function. It's zeros of the derivative, which is where the original function has zero maximum. Yeah. We jump back and forth between the original. Take some practice just to get it in your head. Yes. Okay. All right, guys, let's try one more of these. Derivative with some numbers. Nope, that's p of x, and I'm asking you to do the exact same thing we just did. So find your maxes and mins, find where it's increasing and decreasing. So what's your first step? Derivative, okay. And this looks like it's going to be scary, but it's really not.
Are you finding your
Well, so this is the same as 1/4 x to the 4th. So it's actually really nice. Looks scary, not really scary. So I'll give you a little bit of time here for you guys to try the whole thing. What'd you get for the derivative? Because it's 1/4 x to the 4th. So when I take 4 times 1/4, so it's that. So it's actually much less.
Okay.
Yeah. Guys, just making sure everybody has the right first derivative, right critical numbers. Did you have -2, 0, and 2 on your number line? Yes, okay. I'll let you keep working from there. Just making sure everybody's okay. It is. Yeah. So where it's increasing and decreasing actually shows you where the original max and min are. It's very weird.
Do you have?
Is there like a black background like this? It's easier but you know you can decrease the brightness like further than the setting. So on my phone, if I know that I'm gonna do like upload,
Eventually, what I'll do is like.
Because I can't see my screen. Okay, that's great. Put on all of this. So what are your accessibility? I was thinking about it, like so many people like have like black backgrounds with like I used to have I'm so lazy with it. Oh,
How about you're good? All right, guys. So let's look at it. All right. So did you get minus, plus, minus, plus? Okay. So you can write your increasing, decreasing right away if you want to. So increasing would be from -2 to 0 and 2 to infinity. And decreasing -∞ to -2 and 0 to 2.
I don't understand why you what purpose.
So that tells you where the derivative is above the x-axis and where the derivative is below the x-axis. Where the derivative is above the x-axis, your original graph is increasing. Where the derivative is below the x-axis, your original is decreasing.
Oh, okay.
Okay, I'll show you, I'll see if my calculator, if you'll be able to see both. Because it's interesting to see the original and the derivative and then how some of these pieces line up. All right, so since it's decreasing to -2, that means -2 is going to be a minimum, right? Anna? Okay.
Negative and then positive. Like, when I plug in like -3, I get positive.
No, when you plug in -3, like you can plug it in here or here. So that'd be -3 times 9 minus 4. That's a negative times a positive. Like, no, because it's the zeros of this, so that's what you're testing. Okay. All right. So then we've got a minimum of, what was it, like -4 at x equals -2. And was it the same at, yeah, and at x equals 2. And then our maximum was 0 at x equals 0.
Yeah.
Yeah? Okay. How we doing? Good. Okay. Let me just show you the graphs. I think it will work nicely on my calculator, but we shall see.